Greetings, everybody. So here's another problem I'm taking from my math lab, which I think is fairly involved, maybe more so than some of the others in the assignment. And I'll show you how to think about this one in several parts. That way that I hope it's a little easier to understand. I think if I just did it all at once, it might be easy to get lost in the process. So here I'm going to break it down into very small parts. This video will not show you this entire problem, but I think it'll show you something necessary to get started. So what I have here is this thing called a differential equation. And a differential equation is an equation that involves a function and its derivatives, okay? In the proposition here, the claim is that this function, which involves hyperbolic tangent, is actually what satisfies that equation. And our job would be to check or verify that, okay? So a differential equation is an equation that involves a function and its derivatives. And this is the proposed function that is the solution of that. Other than that, it tells us that this differential equation is a model for an object in free fall with some aerodynamic resistance, okay? But let's not worry about that. So let me, before I show you that this function is a solution to that differential equation, let's talk about this. What's the difference between an algebraic and a differential equation? So we'll start small with this. Well, in an algebraic equation, the solution is a number. Like I take this one. This is an equation. It's just algebra. I can propose a solution, 2. I can put 2 in for the x, do all the math, and verify that it's right. Now, that's kind of what's happening here. I'm given the equation. I'm giving a possible solution, and I want to check or verify that it works. It's kind of like this. Is 2 a solution to that equation? Here's how you'd verify that it either is or isn't, okay? And it is. Now, that doesn't mean that there aren't other solutions to this equation. And I didn't show you how to solve this. All I'm doing is showing you that this number, in fact, works in that equation. That's what we have here. Here's the equation. Here's the function that is apparently the solution to it. We would just want to check, okay? Now, that's an algebraic equation. It's a lot like what we have going on here. If you want a simple differential equation to think about, here is a differential equation. It is an equation that involves some function y, which is a function of x, and its derivative dy over dx. And there are some other things too. There's a subtraction, there's a tangent, and so on. But it is an equation that involves a function, y. Y is a function of x. That's what that y is right there. And its derivative. So I got an equation, a differential equation. I propose you this solution right here. What does that mean if this is actually solution? It means if you take its derivative and you subtract that function times tangent, you get 0. That's what it means. You can substitute this function in that differential equation just like you can substitute this number in that algebraic equation and see if it works, okay? So, well, let's see. If I take the derivative of this function, that's what dy over dx is, and I subtract this function times tangent, will I get 0? See, what's the derivative of 4 times secant of x? What's the dy over dx? It's 4 secant tangent of x. Okay. Then minus. What's y? Y is the function. 4 secant of x. Okay. Then times tangent. All right, question mark. Is that true or false? It's true. 4 secant tangent minus 4 secant tangent is 0. 0 equals 0. That proposed solution is actually right. Okay? All right, so that is what's happening here. It will be more complicated to do this checking part because that differential equation is more complicated than this one. And this function is more complicated, but it's the same idea, all right? Same basic idea. So that's what a differential equation is. We won't worry at all about how to solve this equation from scratch. That can be a difficult thing to do. There's another class called differential equations, which you take after calculus to explore that. But for now, all I want you to know is that what you see here provides a good analogy to what's going to be happening as we solve this one as it is.